We're going to look at sampling distributions. I cannot emphasize this enough. This is probably the most important topic in this course. You want to understand statistics, modern day statistics. This topic is number one. Okay. So what are we looking at? And we need to consider, we're going to look at, of course, in this particular lesson, sampling distribution of the sample mean. And this, by the way, is again redundant. I keep saying this. Most of the time, this is erased and just sampling distribution of the mean. But what is a sampling distribution? Period. So when you summarize data, it is one possible value out of all possible summaries that could have generated for that specific sample size. And now the distribution of all possible summaries that could have been generated for a particular sample size is called the sampling distribution of, and then whatever the summary is goes right here. So for today, we're studying the sample distribution of the mean. Again, I could write sample mean, but it's redundant because if you're talking about sampling distribution, you realize that this is about a summary. That's what this is about. So even though I write sample distribution of the mean, it's understood that this is a summary, which means it is the sample mean. Okay. So again, I'm going to reemphasize this part. Whatever we're going to go into today, this has to be understood. You cannot be just parroting words. You have to understand what we're doing here. The notation E of x, like this is function notation, by the way, will be the mean of the distribution we're sampling from. And this, we've been using sometimes this notation right here, mu, for the mean. And because I'm using the variable x as my measurement, I'm going to do sub x here. So this is the mean of the distribution we're sampling from. Okay, so the population we're sampling from has a mean. And that is the symbol used for that value. And the standard deviation, which will also be using this symbol, sigma of x, sub sigma sub x, is SDX. So this is the standard deviation of the population we're sampling from. So this is function notation. It is standard. It is commonly used. This is also commonly used, but when we're talking about sampling distributions, you see this, we use this symbol a lot more. Okay. And again, as I mentioned, we're sampling from where x represents the name of the random variable, the measurements, whatever you like, just like in algebra, you had a variable name. This is what this is. The reason it's called a random variable is because the output from a sample we're not in control of. So the output, the variable, the thing we measure, is random. So that's why this is called a random variable. Now we're not in control of it. Now that's okay. The population mean symbol, standard deviation symbol of the population sampling from. But this is about the sampling distribution. So the symbol E of x bar represents the mean of the sampling distribution of the mean. Okay, so there's a lot of means going on. The sampling distribution of the mean consists of nothing but summaries of some statistic. Now that distribution has a mean, and this is the symbol we're going to use. And we could also use this symbol right here, mu sub x bar. Okay, so this is the mean of the sampling distribution. And as the x bar represents the standard deviation of the sample, represents the mean of the sampling distribution of the mean, and S represents the standard deviation of the sampling distribution of the mean. And again, we could also use this notation, sigma sub x bar, to represent that as well. So this is what we're gunning for right now. So next, we're going to do a quick little simulation to make sure we understand what this is.